did make another video, fifth hour, if someone wanted to see something like 9 minutes long yesterday. So, alrighty. All right, yeah, that sure does look good. Got this from the new principal, I think they gave us these. Anyway, okay. What did I tell you about when we did sine and cosine? I would say input, output, and the kids would have to fill this out. We're just throwing it at you here, right? Right? Okay, why doesn't this have an exact? There is actually a way of getting an exact form of or exact answer of pi over 12. That's not zero. But I'm just saying we don't really care about it. Type it on your calculator and get that decimal. Got it? But really, the key points you're going to have are not even those. It's actually where 1 and -1 here. So if you want to get your highlighter, it's the same as with sine and cosine. Sine and cosine, we only care about, let's do a sine, like middle, high, middle, low, middle, right? Even though I gave you that whole big chart. What you're going to have to find in this are really where 1 and -1 are. And also 0. Don't they have a 0? Oh, good. 0 here. But really, the best representation of this, it kind of shuts down. We should have one more. We should get, let me just get myself organized here. Pi over 2. I'm trying to find pi. We should actually get to 3 pi over 2. And that would be another undefined situation. And then that's where we're really going to see like one complete tangent curve here. And then let me see, 0, 1. Oh, yeah, sorry, undefined for sure. And then that would be another undefined here. Then I'm going to mark on this graph where this occurs, which is where we get to see really one complete one. And then we're going to really look at this one backwards and go into the negative, right? So I kind of stopped short on this chart, but you can see the periodicity of this graph, right? Repeated over and over and over again. Okay, so the parts that why I added this one is here. This is like one complete tangent curve, and it is now on this chart because I put that last one in there. See it, right? Input, say it. And then really what you're going to have is these values. This one, which one was marked? This one. Let me see, 1, 2, 3, 4, 1, 2, and this one. Those are actually A values, all right? And then, of course, well, let's fill out these things and then go back and complete this graph. What behavior is displayed in the graph where there are undefined? What do you think is happening here and here? What should I draw in between these two? It's called an asymptote. And its behavior, it's not that this line is here, but we just put this boundary because of the action of the y's. Now, really what I should do is this, like pi over 2, I'm going to get my calculator out. And I'm going to put it in radians, and I'm going to prove something. I think it's opening. Yeah, it's always so fun how long this takes. What? What? I don't even know what this means. What? What is going on? This is, oh no. I don't think this is even going to work. Oh, I guess it's signed in. I heard that. Upgrades. What are upgrades, everyone? Okay, so what? Yay! Oh my goodness, I was freaking out. I'm glad that happened on the video. All right. Okay. So what was I going to do? What's pi over 2? Well, let's get that as a decimal. Second quit. Pi divided by 2. All right. Good. And then let's make sure we're in radians. Okay. I'm going to do the tan of pi over 2 to prove that we get undefined. We should know that this happens. Tan of, I better do pi over 2. That might be a rounded decimal now. Pi divided by 2. Enter. Error. Yeah, we knew that. Okay, so why did I do this? What about tan of just 1.57? I did. Tan of 1.57, which is just short of pi over 2. All right, this is why we have asymptotic behavior. Enter. Boom shakalaka. That is an awfully large output value, right? Okay, so that proves that this is acting asymptotically there. All right, you're going to find that another one is at negative pi over 2, so I'm going to do the same on the other side real quick. That's not working. It's my pen. Okay, so I kind of proved, I was right here, and I proved that this y value is going off forever, 1.57 when I evaluated it. All right, this is not on the chart, but you know negative pi over 2 is the same as 3 pi over 2, and I did put that up here, that would be undefined as well at all the over 2's. So what I'm going to do now is do the tan. That's negative pi over 2. I'm going to do the tan, where I'm losing my mind here, tan of negative 1.57. Stop, because that's just short of negative 1.5707, blah, blah, blah. Press enter, and you get a huge negative. All right, so we put these asymptotes, not that they actually exist there, we're assigning a behavior. Like, we don't want to keep evaluating closer and closer to pi over 2 and negative pi over 2. We get it. These numbers are taking off drastically at those ends. So that's why we draw these asymptotes, all right? So again, that's the rule for all asymptotes. They don't really exist there. We do it so it helps us draw, and that's the only reason we do it. What is the length of one period? Now, I don't have the time for this. What's the length from here to here? What is that? What's that a distance of? 1 what? Pi. So now we have a different period for tangents than we do for sine and cosine. And that's what we're going to have to remember. All right. Does the idea of amplitude make sense for tangent? What do you think? Yes or no? Amplitude, by definition, defines how high and how low the graph goes. What's the range of this graph? What's the range of this graph? All real numbers. So no exclamation point. For what value of tan of x is it undefined? Now we're going to do this. You ready? It's for every over 2, right? So let's name one of them. The first one that's positive, right? How far away is each asymptote, which is equal to the period. 3, 2, 1, go. Pi. So what do? Add pi n, and we talked about this in previous, I think when we were evaluating on the unit circle, where would all the values be coterminal to this angle? That we added a 2 pi n, just the idea of doing a complete circle again. And then actually this is, I'm going to write this for the first time in forever. Anyone, is Frozen 3 coming out? Yeah. See? All right. Did I ever show you Lexi singing that on her bicycle? No? Maybe we'll do that later. All right. What's NEZ stand for? You know what E stands for? That E? Well, it's actually element of. You know what Z represents? It's the letter that's used to denote what integers are, the subset of integers. I do want to share that with you because this is a common math notation. So all it's saying is pi over 2 plus pi n represents every single integer that you could plug in. So if I plug in 0, I get this one. I plug in -1, I get this asymptote right here. I plug in -2, I get that asymptote. I plug in 2, I get the one that lands at 3 pi over 2. Or I think I plug in 1 for that one. Sorry. This is 0, n for n. This is 1 for n. This is -1 for n. This is -2 for n. And this goes forever and ever and ever. Got it? So we got to get used to this. This is going to happen a lot in the future. So what is the domain of tangent of x? Really, the only way I can think of saying this, you can't really say this in interval notation because it would just be like there's a whole bunch of interruptions. So now we're going to go back to set builder notation and use the not equal to sign. And what a not equal to sign means is the domain is everything else but this. And I'm going to write that NEZ one more time, just so you're writing it one more time, so that if you ever see it in the future, you could just say where n is an element of integers. Mathematicians are lazy. They don't want to write all those sentences. That's why they make symbols. That's true. That's like log base e. They make that ln. because that's now not 4 letters, but 2. All right. It's really true, I think. But I think they said, oh, but that means natural log. Then why isn't it NL? Huh? All right. Anyway, mathematicians, bums. All real numbers. Right? We already said that. Correct? All right. Now, I guess we gave up, but I could do this real quick. What's cotangent? The, not inverse, it's the flip of tangent. So I just have a quick question. What's the flip? I don't know why I can't find it. Oh, it's over here. That's why. I expected them to have a negative. What's the flip of 0? What is the flip of 0? It's not 0. This is 0 over 1, so what's 1 over 0? So what can you expect for cotan? A what here? An asymptote. But then what's the flip of undefined, which could be 1 over 0? 0 over 1, right? And then what's the flip of 0? Undefined. So you're going to like cotan better because, well, let's go back to tan. I know I said this is our first complete curve because of what we have in our chart, but this is usually the first curve you're going to have to draw of tangent. And what's bad about tangent is it has a period of pi, or whatever the period is, but 0, 0 is a point, and you have to go half the period right and half the period left for the asymptotes. Whereas cotan, whatever the period is, unless we're shifted right and left, I have to keep saying that, the period starts with an asymptote, and then the next asymptote ends at wherever the period is. That's why we're going to love cotan a little better than tan. All right. And then why is this like this instead of increasing? It's because of the flip of those y values. Right. And that's that I guess we can't really investigate. What I used to do is put cotan right below tan and then just flip all these y's, and then you would get the picture that you'd expect to see. So you're gonna have to remember tan is what? My hand is going up as I read left to right. Tan is increasing. Oh, by the way, what's this concavity from here to here? Down. And then what's this concavity from here to here? Up. So we got some concavity things. And then cotan is anyone? Decreasing. All right. But really remember, cotan has a different starting point for those asymptotes. All right. All right. And I guess that's all I have to say about that. And then one more thing. Here's one. You're gonna have to find these 3 key points. You're not gonna have to go, and fill out that whole chart. It's really just 3 points and 2 asymptotes. You got a period, right? And then cut and paste and do another period. Tan's a little bit wonkier because you're gonna have to take half the period to get this picture, and then usually we do this other one if I ask you to grab 2 of them, the one to the right, and try to get 2 complete pictures of it. So you got to remember these rules. I'm not going to write that down. Tan, half the period right and left from 0, 0, asymptotes. Cotan starts at 0, period is the next asymptote, and then you can cut and paste and do some more. Okay, so this is going to be kind of hard to do because I already wrote this, and then once I change the letters, then this domain changes. So let's put it in that set builder notation. X cannot equal pi over 2 plus pi n. Let's not write that n-e-z, or put it up here, n-e-z. And then anytime n is used in here, we have, that defined. I don't really know how else we could do that. I really don't think you can do that in interval notation. And maybe you can, and I'm a bad math teacher because I don't know that knowledge. What is the amplitude? There isn't one. But here is what A is. A is these points. This is what A is going to be. So when I change this from 1 to another number, that's what A is going to define. It's going to define those shaping points. Gives it shape is all it does. It's not really a big deal. Yeah, I guess so. I thought I said no, but go ahead. Didn't you hear me? All right. Anyway, and then the period. Man, she's running out of here. Okay. The period. All right, what is the period? Pi. And then the equation of all asymptotes. Hey, you know what the equation of all the asymptotes are? Turn that into an equal sign. That is 100% related. Okay? because that's where the graph is undefined. That's the interruption, so that's where the asymptotes are located. Okay. And then the domain for cotan is, you know what it is? It's just x such that x is not equal to pi n. Why does that work? What happens when I plug in 0? What do I get? What happens when I plug in 0? What do I get? Well, no. When I plug in 0, I get x equals 0. You missed it. I know what you're saying there, but what happens when I plug in 1? I get x equals 1 pi. What happens when I plug in -1? X equals -1 pi. So x equals pi n doesn't equal. So therefore, the equations of all the asymptotes does equal. Okay? NEZ up there. Range again. Oh, kind of getting tired from eating that big panini. Weighing me down right now. How'd the onion smell over there? Good? That's good. Amplitude, none. But yet again, oh, I did it on cotan. Same thing with tan. These 1 values will turn into whatever A is defined by right there. Those will be A and -A. So we are going to say what A is. It's just, yeah. Okay, now that's the period of the parent functions. So when I get new functions, this is now the comparison, not 2 pi. You're going to have to lock that in your brain. Sine and cosine, the period's 2 pi. Tan and cotan, it's pi, just by the nature of its graph. So when I do this one, here is the period. Yeah, I hate these two. All right, but anyway, pi over 3. That is the period. It's pi over b. So we have an a tan b of x. A is, what's A? What number is A? What's invisible there? 1. All right, I don't really care. And I'm really going to fight for the test that you have an axis here so everyone's graph is in the same spot when I'm looking at your work. Okay. And I think maybe we could go by 1, 2, 3, 4. So let's go like by 4 tick marks there, but just mark 2 every 2 just for spacing. I guess I do look like I'm off center. And actually, I went too high there, but that's all right. It's no big deal. Okay, so what's the period? Pi over 3. I'll fill in the other stuff. So what do I put here if you were listening? What is half of the period? What's half of the period then? Pi over 6. And again, this is the fractionally challenged. If you're like, whoa, where did that go? Or where did that come from? How did you get that? You just take half of pi over 3 and it drives me nuts. I even do this with the regulars. Guys, come on. What's half of pi over 3? I don't know. You got to multiply across, right? This is so easy to figure out. All right. And then y, this is just what tangent does. This is where the asymptotes are. This isn't shifted right or left. So that's at least what I have. All right. And then what do you think this value is fractionally? How far is this? It's a fraction. What of pi over 6? Half. What's half of pi over 6? Pi over 12. And then this is negative pi over 12. I'm going to put that up there because I know what's going on. And then I should be able to ask you, I should be able to pick you out of the crowd and say, hey, whoever, what's f of 0? What is f of 0? What is the first point for tangent? 0. What's f of pi over 12? 1. That's the one. Let's go up by 2 on that one too. Half 1. And then what's f of negative pi over 12? The answer is -1. So I got to put a 1 and a -1 there to mark those. And then something looks wrong. Oh, I did. I put the point in the wrong spot there. I knew something was off. It was all cattywampus. Now, don't do this. Oh, this always drives me nuts how people do their tangent graphs. Come down here and then approach that, kind of flatten out, and then come down there. That's about as good as I can get right there. There isn't any little squiggly in between those 3 points. It kind of comes. If I would have put this more like 1 down, you would have seen more of a flattening because I decided to go by 2, go by halves. You know, when you mess with your scale, it distorts the graph a little bit. Now, you want to get nuts? Let's get nuts. 1 pi over 12, 2 pi over 12. What's next? What's 3 pi over 12? Pi over 4. This is the fractionally challenged that can't do this. 3 pi over 12. What's 4 pi over 12? 2 pi over 12, 3 pi, 4 pi over 12. That's what? Pi over 3. What's 5 pi over 12? What? Do you remember this lesson? Oh, yeah. Yeah, you were. Where are you going? Keep this. For this lesson. All right. Have a good day. I had another heavy customer. I'm just kidding. Thanks. He's fine. Oh, where's my pen now? Interruptions. Okay. What's wrong? Everything okay over there? The 3 ditchers? You guys all right? What's 5 pi over 12? Nobody answered. What's next? Pi over 2. So I think it did say 2 cycles. Okay, and then you get that that quarter of the period value. What's wrong? Is everything okay over there? Okay. And then I should be able to ask, what's f of pi over 4? What's the answer? What's f of pi over 4? Here, I'll give you a hint. I have to move this. What's f of pi over 4? What's f of pi over 4? What's f of pi over 4? Okay, some people are barely whispering it on their deathbed. What's f of pi over 3? 0, 1 person. What's f of pi over 5 pi over 12? Oh, there's more people. And then that's 2 periods worth. I guess you could choose either way. It doesn't really matter. Tangent's a little weird. You gotta get that halfway done, and then you have to get one more either right or left. Okay. Oh, all right. Domain. Let's get used to that. X line. That's X such that X does not equal. Okay. Where's our first asymptotes? Pi over 6. You could put negative pi over 6 there. You could put pi over 2 there. Does not matter. But then how far away are they? The starts with the P. P-E period N. Okay, everyone is pi over 3 away, which is the equation of all the asymptotes. Just turn that into an equal sign now. Because these are equations of vertical lines, so it's x equals. So that is and this is always, this is never not going to be the case, right? We okay over there? Tangents fun? Okay, next. Really not a big deal. Oh, but you got to read cotan. Yeah, I don't know why. It's fine. I think it's better to have this blank when we shift right and left, because then you have choices, and that's going to be weird. I was thinking about last night that I thought we were shifting right and left today. And it's like, oh boy, that one's going to be the hardest lesson of the whole graphing section. But this isn't too bad. All right, so period. Okay, so here we go. Why is it pi? Because it's cotan and tan. It's not 2 pi over, it's pi over. These are the big mistakes that people make. There's really no math to do on that. That was weird. It didn't write it first. Okay, what do I know about cotan? Oh, I know it starts with an asymptote. Maybe I'll change colors. And it ends with an asymptote. So I need 1, 2, 3, 4. I need those 3 key points, and then the 4th point is the next asymptote, because I need my 1, 0, and -1 points. Wrong! What are those points going to become now? Not 1, but what? 3. Now, I'm going to cheat. I should have kept the first one just going up by 1 so we could see the differences. But it doesn't matter. You can mess with your scale. You should be good about this. This is why you're going to like cotan as well. Guess what? Cut and paste and make them negative. So once I find the first ones, I don't have to do that fractional math anymore. Cotan's a lot easier. All right. So what's the domain? We'll get that. Well, we can do it now. X equals 0. Why would I write that? Actually, sorry, does not equal, because this is domain. I was thinking of asymptote, so I'm going to put my set builder notation in. And the period's pi, so it's pi over 2n. All right? And then the equation of all the asymptotes are x equals pi over 2n. I plug in 0, I get x equals 0. I plug in 1, I get the period. And that's where the next asymptote is. Love it. Range, fine. Let's get it out of the way. Negative infinity to infinity. Okay, here we go. Fraction time, boys and girls. What's x over 2, or sorry, pi over 2, half of that? What's that answer right in the middle? Pi over 4. What's half of pi over 4? Now it's the same game as sine and cosine. 1 pi over 8. 2 pi over 8. What's the third one, everyone? 3 pi over 8. Is the last one 4 pi over 8? Yes. Now be careful with this one. What's f of pi over 8? It's not 1 or negative 1 or 0. What is it actually? It's 3. We're going to go up by ones now. So we're not going to really see the major difference between this cotan and tan. It is stretched vertically, but I decided to only go by ones instead of halves compared to the previous one. What's f of pi over 4? Nobody answers. I need the Cricut app. 0. What's f of 3 pi over 8? Someone. Why is it during quizzes you're like, the answer's 7? All right, but you don't answer any of these. Yep. Anyway, it's a thing. All right, and then it's negative. Well, let me see. So this is going to be, that's going to be down here. So, well, actually, it won't be in the way, but I kind of know what's going to happen here. Cut and paste. And I know this is going to be down here. So, and then this is 1, 2, 3, 0, 1, 2, negative 3, and then there's 2 periods. Does this seem hard? Have you ever seen this before? Has anyone ever seen tan and cotan? Yep. And what? Huh? Oh, just mess around. So you said a teacher had you mess around with it last year or something? No? Just for fun. Yep. Yeah. No, it's good. No. Reason why you. There you go. Bam. Oh man, shots fired. Not a gun. That's not. It's just like a verbal shot. Don't everyone calm down on the internet. You can't do that. Cancel Mr. Samuels. I gotta really watch what I say now these days. Whew. You know, I tell teachers, yeah, I video every lesson. You go, why would you do that? God, you're gonna get in trouble. I just said God. Oh, I'm done. I mean, I can't do anything. You know, it's just like, I'll sanitize all my language. But anyway, okay. So what do we do with plus 1? What do we do with plus 1? We make a dot. There's really not much more to the word. Dotted new like axis. This is so I know like input output where I'm putting things. That's where I base the A value from, off of. Okay. And then that's where the zeros are located now. Got it? So whatever is a 0 now is plus 1 because 0 plus 1 is 1. All right. Now, what's undefined plus 1? That's a weird question. What's undefined plus 1? Undefined. So what I'm saying is the asymptotes are still going to be located, even though, it's not. I hopefully you understand what I'm saying there. Okay, and then what's the period? There's nothing done there, so the period's pi. And then the domain for this, again, going over this quickly, it's half of that. We have pi over 2 plus pi n. Remember, I have to take half of the period to find my first asymptote. All right. Okay, and let's go ahead and do that. So 1, 2, this is period of pi. So this is pi over 2. That's where I have an asymptote. Okay, why? It's the rules. It's what I just denoted with you with tangent. Okay, that's why I said undefined plus 1 is still undefined. You still have asymptotes there. All right. And then this is negative pi over 2. And then everyone, what's half of negative pi over 2? Negative. Oh, no, I want this down here. Pi over, I still haven't heard it. 4. And then this is pi over 4. Because I know what's going to happen with this. What's going to happen with this is it gets flipped, right? So what's f of, let's start with pi over 4. What's f of pi over 4? Consider the plus 1. You guys aren't answering anything anyway. So what's f of pi over 4? it's actually -1 because that's 2 down from the new axis. What's f of 0 now? What's f of 0? Nobody answered. What's f of 0? 1, not 0 because it's moved up 1. And then what's f of -pi/4? It's actually 3. So there is an a value we care about. We just can't call it an amplitude. You just can't do that. All right. Oh, I got to do another one, but I'll go ahead and draw this one. So that's all that happens. Just gets moved up 1. And that dotted line could be, you don't have to think of that as an asymptote. It's not. It's just like a new x-axis. All right, and then I think we already did this math. 1 pi/4, 2 pi/4, 3 pi/4, 4 pi/4, 5 pi. I feel like I'm doing something wrong here. Pi/2, what? 2 pi, 3 pi/2, 4 pi/2, 5 pi/. That's what I was doing wrong. Pi/2. Wait, one. Sorry, let's start over. 1 pi/4, 2 pi, 3 pi/4. I was making a mistake there. This is 3 pi/4. Got myself lost there. 4 pi/4, 5 pi/4. I stopped short too. What's 6 pi/4? Okay, so then look at the parent function on that page because the period didn't change. These are the same values where the asymptotes are. So this is 3 pi/2. Yeah, I was getting all goofy there. And this is 1. Oh, no. That's what I was trying to avoid. Oh, well, doink. Not changing it. And then we got that. So it is a little bit of a... Was that the first bell, by the way? No one's saying the damn word. It's just so funny. It's so awkward. Just like at home at the dinner table and, and then Lexi's sitting there, how was your day? And she just goes like this. Why are you talking to me? That's what her eyes say. Teenagers. All right. Hey, what's the reciprocal of 0? Undefined. Isn't that what cosecant is? Isn't cosecant just the flip of outputs of sine, right? So what does cosecant also have then? Cosecant must also have a asymptote. Now I do like this. I wish they would have done the decimals. I guess I could do that real quick. I don't think anyone really hit what? You're not leaving? Oh, I thought you were leaving. Okay. So here's root 2. I'm going to be really slow on this. Root 2, enter, divided by 2. And then you do have a 1 over x button. Where is it? Oh, it's the negative first button. Boink. So what is that number bigger than? 1. So when I flip root 2 over 2, I get 1.7. As a matter of fact, we're going to get this over with. Oh no, it's in my 5th hour. Someone has a TI Inspire, which does have a cosecant button. He's the only one in class. So where are we talking about? Right around here, pi/4. Let's get close to 0, and I am in radians. So we know that the sine of second quit, the sine of 0 is 0. So what's the sine of 0.001 radians? How would you do that? Because I'm getting right to the right of this 0, and then seeing what the answer is, and then I'm going to flip it, because that's what cosecant's answer is. Enter. What is that number? What is it, though? Point, anyone? 0.0009. I had to teach that in ACT yesterday when we were doing I numbers to a power. Did you know your calculator can do that, by the way? There's Mr. What the heck was that? Oh, cancel Mr. Samuelis. All right. I thought it was this. Oh, I hit alpha. What a buffoon. Did you know you could do powers of I on your calculator? And sometimes that comes up. But then this is what we ran into. I raised to the 123rd power. What? They don't know what that is? What does that mean? Small decimal. 0 minus. Someone say that. That's just negative I. You know, I to powers of 4, 8, 12 is 1. You guys know that? I don't know why this has nothing to do with the lesson. I just thought I would share an idea. But anyway, what I wanted to do, nobody is impressed at all. Okay. Trying to help. Flip. What's a flip of a very small number? Very large. So what I'm trying to get you to understand is this. Here's how you're going to graph cosecant. What's the flip of 0? What's the flip of 0? Undefined. You have an asymptote. What I just proved is this point's way up here. Hey, what's the flip of 1? What's flipping 1? What does that become? No. What's the flip of 1? Some of you are laughing over there. What's the flip of this? It's somewhere up here. What's the flip of this? It's way up here. This is what's going to happen with cosecant. That's it. What's the flip of 0? Undefined. What's the flip of very small? Very large. Say hello to part of the cosecant graph. Hello. What's the flip of negative 1? Negative 1. I can't do this anymore. You just sit there and don't answer any questions and not be involved in your own notes. What's the flip of very small negative? Really big negative, which is actually incorrect to say. The more negative a number is, the smaller it is, right? Anyone? Yeah. And then the flip. So you get it. You get it. Asymptote. What time is it? 40 what? Oh boy. And then at negative 2 pi is another asymptote. And then we got this flip up here. So it does look like a series of parabolas, but it's not. All right. What's the matter? What's wrong? And then, isn't that the cosine kid? I don't even have to look at the chart. What's the flip of 1? 1. What's the flip of 0? Asymptote. Not doing any asymptote behaviors on the calculator. Nobody was impressed. Nobody. Give me the stink eye like Lexi at the dinner table. So guess how you're going to graph these? Well, I'll tell you. You're going to graph these by graphing either sine or cosine first, and then it starts with an F. Flip. And you will not graph this as a solid curve. I don't want to see that. You're going to graph it as a dotted because it's not the answer. It's just helping you describe. Just like why the asymptotes are dotted. They're not part of the graph. They're just forming the graph, right? So that's what we're going to do. Okay, and then what are our domain issues for this? This is wrong. We got to change that. That's cosecant. Just a little boo-boo there, all right? Change your notes there. And then the domain is, well, where are my asymptotes for this one? This is cosecant, so that's wait. Oh, right. I'm wrong. I thought we were putting these all together. We've already did it. You know what? I don't have time for this. Just we already know what those are. We did that in our previous notes. I care about this. All right. So where do we have asymptotes? Every half period. Oh, let's do this again one more time. NEZ every time I write it, everyone. NEZ. What's the range? What is the range? Interesting. What is the range of cosecant? Is 0 part of it? No. And where do these go off to? Infinity n? So the range is really weird. It's negative infinity all the way up to negative 1, and then there's an interruption in the middle, and then 1 to infinity. All right, and I'm probably losing myself time here, but what's the amplitude? What do you think about amplitude? Does it exist in this? No, there's no high and low point. These go off to infinity, so there's none. But this is the A value. The A value is going to be important. What's the period? We're back to 2 pi. So only tan and cotan have a unique period. Domain, sorry, I screwed that up. Add this. Remember, domain means I can't equal those, but it equals everything else because the equation of the asymptotes are they do equal this, the parts of the graph that don't exist. All right. And then the domain is very similar, but this is a little off. And then you're going to be a little annoyed with secant. Secant's a little tougher because it's a little shifted, is what I like to say. Pick one of these, any one of them. You wouldn't be wrong. I just picked the first one that's to the right of the x-axis, y-axis, y-axis, y-axis. And they are all half a period away. Again, I screwed up. it's not equal to in the set builder notation, which you will see potentially. And then this is pi plus pi n. Yeah, all right. Amplitude, no. Yeah, yeah. And then the period is 2 pi. Range is the same. All right. Do I have any that are shifted? Can I just do this one and be done? I mean, do you get the point? Okay. So what do we have here? We have a cosecant. Is the bell about to ring? What? She's putting her stuff. Oh, it's water time. I didn't realize that. Sorry. 3 people just grabbed their water. Sorry about that. I guess I'll go get mine. I don't know what to do on mine. It's not working. Cheers. Sprinkler. Woo! Yeah, we needed that. Everyone good? Okay. All right. So where am I going to put my dotted line? 1. Okay, I'm not talking about an asymptote. I'm talking about a new axis. Who am I going to graph first for cosecant? Who am I going to graph? Sine. So you're going to graph sine. You got to know that cosecant's related to sine. What's the period? 2 pi over 3. Now, I did pick an easier one, but it's okay. Imagine if it was secant, you just graph cosine the way you need to. And then what's our amplitude? Not even listed. There isn't one. And let's fill out all the other stuff after. So the period's 2 pi over 3. So for sine, let's go by 2's again. 1, 2, 3, 4. This is the period. I don't know where to put it. I guess I'll put it here. I'm just afraid that my numbers are I'm gonna try to think where we end up here. I think we're good there. What's half of 2 pi over 3? I can't teach fractions to you anymore. You're in honors, you should know. I'm gonna have a fraction problem with the others. I know it. It happens every year. They just can't do a fraction and are blown away by what that number is. What's half of pi over 3? Pi over 6. Okay, so what's gonna happen? So I'm gonna put this up here. I hope I'm doing this right in my head. 1 pi over 6, 2 pi over 6, say it. 3 pi over 6, which is pi over 2. I think I'm okay here because I think I know what's happening with this. Hopefully I didn't screw up. All right, and then how do you graph sine? Well, 2 is the amplitude for sine, but it's up 1. So where is the first point? F of 0 is what? Is it 2 above? Is it right on this dotted line or 2 below? Which one is it? Wrong. It's right on this line. Because what sine? 2 what? 2 what? Bulls. But they're... Okay, so remember I just did that. Where's pi over 6? Is that -1? Is it at 1 or is it at 3? Which one is it? It's at -1 because this is flipped upside down. What's pi over 3, comma? Pi over 3, comma? Wrong. 1. Having a rough day. All right. And then what's pi over 2, comma? What's pi over 2, comma? I got to rip it off like a Band-Aid. I just got to say wrong. What's 2 pi over 3, comma? 1, not 0. All right. And then you can cut and paste. Can I just do 1 cycle? You can do 2 cycles on this. But then what happens at the zeros? You have an asymptote. So this is why I don't need to even graph this. But it's not a 0, but it is. Undefined plus 1 is still undefined. Right? So that's why we're still drawing asymptotes there. And then you could probably get away with this. That point's shared, and then this is what sine's doing. So you flip that upside down and draw a curve, colored in. And then sine would do this, dotted. So you flip that above and do that. And then you could cut and paste it. Oh, whoopsie. Did I not? Wait. Oh, I was supposed to do 5. What a maroon. Whoops. I stopped 1, 2, 3. Wait, 1, 2, 3, 4. Oh, no, I ran over it. Ooh, I'll mark you wrong with what I just did there. I didn't draw my boundary here. My bad, dogs. Nobody. Rough.